components. The four key components of this topic of 2.1.2 of thinking ahead is going to be we need to identify the input and outputs for a given situation. We need to determine the preconditions for devising a solution to a problem, and we need to discuss the benefits, nature, and drawback of caching, the need for reusable programming content. So, if I start with the first specification, which is the need for identifying the inputs and output for a given situation. So my question to you, the first question to you is that if I have a given situation and I want to identify input and output, the first question from you is that can you tell me about what is this input and output or what is the difference between them?
Okay, so basically the input is the one that you're basically trying to put in order to make sure that a real output is given in and an output is basically like the result of the calculation or
Okay,
algorithm.
that's excellent. Can you give me an example?
For example, if you're like working in a shop here, you will
Mm-hmm.
need to like input the price of it.
Mm-hmm.
No, not the price. The item that you're buying, and the
Mm-hmm.
output will be the price, how much it costs.
Okay.
And if an input, yeah, if you like shopping around, yeah, the input would be
Okay.
how many things that you're buying, and then the output will be the total cost of it.
Okay. Okay. So the thing about thinking ahead is that in computational thinking, thinking ahead involves planning the input and output. This is a useful technique to apply on a range of problems. For example, you could ask that what answer do we need, or what do we need to know, or we have before we can get what we need, or how can we turn the inputs into required output. So the first thing is that you need to identify the inputs and outputs for a given solution. And thinking ahead is like the first topic that I discussed was thinking abstractly. Now this is thinking ahead means that you are moving forward with a given situation and you need to work on with a given number of inputs and outputs and says how you can solve the problem. So thinking ahead about how the software needs to function and how it will be used, it provides the programmer with insights, with information that will going to inform you about the design of this. So the output that you are getting from the software is definitely based on the input that you are giving. Like right here, you gave me an example that Mr. For example, if I am giving a value to the input, so it generates an output as well. So the output from any software is basically the key element for the design. So when the functions are being created or are being described, this provides you a description as how your output will look like. So in thinking ahead, the first thing is that you need to identify the inputs and outputs for a given situation by depending on the things that what you said exactly, like the areas that you have to give input and what areas that will generate an output, right? Like for example, when you are designing a solution that is thinking about the different components of the problem, you need to check that how that problem can be handled into the best possible way and how different components are going to align together to work with it. So thinking ahead allow your programmers to consider problems or difficulties that may arise when that software is being used or when you are about to use the software. So you need to correspond to those areas, such as input and output, as how this works. So by taking these factors into consideration at an early stage of your software development, as a software programmer or as a software developer, you can actually design strategies to make sure that your program is easy, user friendly, and intuitive to use. This is important at the beginning of the stage because if you consider it later on, so it might create difficulties for you. This is why this is the second stage. So when we are talking about the core, do you know what does it means by core? It means that when I am starting designing or developing the software, so all of my computational problems are going to consist of the inputs which are processed to produce an output. Like the same example you give me that, Mr. If I'm giving a price, a value to a software, so it is going to generate me the display or maybe print me a receipt of something. So this is basically a very common example, like information you are giving as an input, it is being processed to produce an output. So input could include any data that is required to solve a problem or that is entered by the user. So the order in which the data is input and the method of input, it should must be taken into consideration because your output is going to based on that. So as the outputs are the results that are passed back once the inputs have been processed and the problem is solved. So designers must decide on a suitable data type, structures, and method that how to present this solution. So it's like information uh, does not necessarily have to be output on a screen or monitor. Sometimes when you are producing an input, output data will also may going to contain visuals or audio as well that might require some speakers or printers as well. So like when you are giving an output, it's not like that you are just giving a piece of value. Any input you are providing, it is going to generate an output, and it could be in the means of like videos, audios, visuals, information, or any type of data. But thinking ahead here is to make sure, like in the future, that how your software is going to process that. So, do you get my point? What I'm trying to explain here?
Yeah.
So, let's take some of the examples here. You must be able to identify the inputs and outputs that would be required to form a program in a given scenario. For example, a program designed for an ATM. Can you see here the inputs and output? What is the input?
The transaction type, the card details, and the PIN.
Yeah, and the deposit, balance, withdrawal. It's like when you go onto the ATM and you click on the desired button, it outputs it basically outputs the selected part. Like if you are taking a withdrawal, so it will give you the cash. If you are asking to give some balance, so it will give you the balance like this. Even though when it captures your card details using a card reader, they are going to check your balance and display the total balance as well. And also, if you are entering a pin via a keypad, so if withdrawal is selected, it will dispense the cash or print a receipt to confirm the transaction, or speakers provide feedback as well. So this is basically a valid example as how an input and output is being processed in an ATM. So you might also be asked about how this data is captured or how it is relayed back to the user once it is processed. So the input device required maybe here would be a touch screen, a magnetic stripe, card reader, and keypad, while output device would include a monitor, cash dispenser, printer, and speaker. So as designer begins by considering what outputs are required of the solution based on the user's required requirement. So the next step is to basically identify the input required and how they can be processed to achieve these outputs. So, see, like the output from any software is the key element for the design, and when the function of the programs are described, they officially like what output it produce. So, see the example here. Some of the outputs and inputs for a simple maze game might include like output is image move on the screen. So input is key press for a direction. Output is like sound to integrate collision with the word. So key press for a movement, and sound when rewards or objects are intercepted, player name. So like this. See, they are actually talking about this maze game, and the structure chart of this maze game is also here. Python code is also here. But okay, so that's it for the first part of this, which is identifying the inputs and output of a given solution. The next point that we have to discuss is determining the preconditions for devising a solution to a problem. Do you know what is a precondition?
Is there requirements that must be met before a program is executed?
Yes. Excellent, excellent. That's correct. And what I mean to say is that you actually knows what we are doing. That's a good part. So you already know the answer. But in A levels, you just need to learn how to deliver it exactly. That's why for a one single thing, I gave you a lot of lecture and just keeps you hitting you with the lots of information, just like so that you can actually get what I want you to write in your exam. So you are totally correct with the precondition as well, that these are the conditions that before must be met, but you need to think of it as a programmer here. So these are the requirements which must be met before your program is being executed. So if the preconditions are not met, that means that the program will eventually fail to execute, or it will return an invalid answer to invalid answer. So to specify preconditions, that means a subroutine can safely expect the argument passed or what it will to be meet the certain criteria. So preconditions, you can test them with the codes, so they are often documented as well. Do you know what is a subroutine?
It's a sub program that is a small program that can fit inside a big program.
Subroutine is actually self-contained section of your program, or you can say a part of your program that is used to complete a specific task. And these subroutines are divided into functions and procedures. So for example, you can see here there is a function pop, which is going to remove the last item added into a stack. Do you know what is a stack?
No.
Uh, okay. I
Oh
want
yeah.
you.
Oh, stack. Oh yeah. I thought you meant. Yeah. I thought
I
you were
want.
talking about in a different context.
Uh, yeah. But I just want you to look at this picture and listen. For example, if I add the first value, what is the first value to be added here? This one,
The
right?
bottom one, the
The
bottom plate
yeah. And then the second value, third value, fourth value, fifth value,
goes up.
sixth value, seventh value, eighth value, right? So the first value to be added is going to be the last
Bottom
value, and the last value to be added is going to be the
top
yes. So if I want to remove values from this structure, am I going to remove from bottom or from the top?
top
And if I want to add the values, am I going to add from here or from the top?
top
Yes. This is a data structure of stack. And this is a function pop. Pop means like to remove that item. So if we are working with determining the precondition for devising a solution to a problem, so some of these preconditions can be specified within the document, and it might can include some of them like requirements for the device specification so that you are able to run the program, the operating system required to run the program, any necessary additional software or hardware, and when you are working with the development of your program or routine. So sub-programs will need to correct the data passed to them. Input data should be validated as well, and actions needs to be validated so that your program is not being error. There is not any sort of error in that. So when we are talking about the precondition. We are like talking about the need to establish and to ensure that the routine or the code of your program or your algorithm is being executed successfully. Because when you are creating the algorithm or the code, you need to work on the following things, like what is your order and how you are going to make the things. So in chapter number 4, there are algorithms for popping the data in stacks and queues. So we are going to discuss that there. This is basically abstract data type, but I think they will cover this here later on. Do you know what is this function being doing here?
Uh,
Wait. First, let me explain you the concept of stacks. All right. So a stack is basically an example of a data structure which follows last in, first out principle. Do you know what is this?
a stack is linear data structure.
I mean last in, first out.
Oh, LIFO collection. I don't know. I don't know.
If you are going to, I mean, read it carefully, you will understand. Last in, first out.
LIFO.
Last in, first out means, okay, no problem. I'll get back to this again. It's basically a collection of elements where you have two options, push and pop. So stacks are
Oh.
used to manage data in a way that most recently added elements are the first one to be removed. And how this work is, see this. Can you take this example of a common analogy of a stack, that is when you are washing dishes? As more dishes are about into the washing, they are added to the top of the stack of dishes. And when you have finished washing a plate, you take the next plate from the top of the pile. So let's say, see, what is this? This is push. Wait. Yeah. What is this? This is push. Are you getting it?
Yeah.
You push one value, you push another value. And what is this?
Pull.
This is pop.
Oh, pop. Pop.
So when you add the values, this is push. And now when you are removing them, this is pop. Is it clear?
Mm, yeah.
See, push, pop. In a stack, you have two things. One is push, one is pop. What is push? This is when an item is added to the top of the stack. So if the stack is full and the item cannot be added, so there is an error raised. And a pop is an item where it is removed from the top of the stack and returned to the program for further processing. So let's say that we have a stack that contains three values, 21, 3, 5. Now, If I go right add 7, this will add 7 on top of that. If I say add 15, this will add 15 on top of that. And if I say pop 15, this will remove them. Pop 7, this will remove them. So is this clear? Now, this word
Yes.
says last in, first out. Are you getting it now?
Yeah.
Because the last item is going to be the last item to be out, right? Last in and the last ones will be. So this is going to be used. This is in a way that ensures that the most recently added element is the first one to be removed. Are you getting it?
Yes.
Now, can you understand what is happening in this code?
Yeah. Pop is to like remove items.
Yeah. Okay. So this function is actually checking that the stack is not empty, whether the top pointer top is greater than 0. So this is clearly without this condition being met. So no items can be removed from the stack if the top is 0. Are you getting it? Because if the top
Yeah.
is 0, there will be no value. So it is important to check this is precondition. So you can eventually stop your program from being crashed. So preconditions can be included within the document as well, in which case it is the user's responsibility to ensure input meets the requirement specified by these precondition. So a common example can be a factorial function as well. Do you know what is a factorial?
Like where you like multiply a number but then goes down.
Yes, exactly. So it's like rather than checking the argument passed to the function, it should must be non-negative. So this should be specified within the documentation that is occupying the function, including the precondition as well. That is going to reduce the time and complexity of the program, which is going to save your time later on as well. What is an argument? Arguments are the values that you are going to pass into your function, procedure, or your subroutine. Are you getting it?
Mm, yeah.
So the purpose of precondition is to ensure that the necessary checks are carried out before the execution of a subroutine, either by the user or as a part of the subroutine, and by explicitly ensuring these conditions are met, subroutines can be reusable again and again.
Mm.
Then we have in our syllabus the nature, benefits, and drawback of caching. This is the third part of the syllabus. So, do you know what is caching?
What is what?
Caching.
It's process of storing instructions in cache memory.
Okay. I'll give you 1 minute to go through this information and then you will tell me what is caching. These three paragraphs. Can you go through them? Are you
Done.
done? Okay. Now, can you tell me about caching?
So caching is the process of storing structures or values in cache memory after being used and may be used again. Mm, which
Okay.
um which will save a lot of time, which will be needed to store and retrieve instructions. The
Okay.
the web page that a user frequently accesses are usually cached. The next time it is accessed, it can be loaded without any delay.
Mm-hmm.
Prefetching can also be good, in which algorithms can predict instructions which are more likely to be fetched soon.
Mm-hmm.
And less time will then be spent by thinking ahead. One of the biggest limitations is the accuracy of algorithms that are used. They can only be provided as a prediction as instructions